Hi guys, welcome back to the channel. Well, on to the next problem. Lead code 1338 reduce array size to the half. Uh, this is for 5. If we complete this, we'll have 4 more problems to take care of. So lead code, this is 25th problem in the list. And again, lead code 1338 reduce array size to the half. You are given an integer array. You can choose a set of integers and remove all the occurrence of these integers in the array. Return the minimum size of the set so that at least half of the integers of the array are removed. Okay. You are given an integer array. You can choose a set of integers and remove all the occurrences of these integers in the array. All the occurrences, right? Okay. Return the minimum size of the set so that at least half of the integers of the array are removed. So we have to remove at least half of the integers, which will make uh, the array to its list. For example, if we remove all threes, we'll still have more than half. So we have to remove the next most frequently occurring value, which is 5. Then more than half is removed. Now we'll have you are given an integer array. You can choose a set of integers and remove all the occurrence of these integers in the array. Return the minimum size of the set so that at least half of the so it is at least half of the integers of the array are removed. Minimum size of the set. Choosing 3, 7 will make the new array 1, 2, 3, 4, 5, which is 1, 2, 3, 4, 5, which is 5. So 3 and 5 will make half the array, the new array, which has size 5 equals to the half of the size of the old array. Possible sets of size 2 are 3, 5, 3, 2, and 5, 2. Didn't get it. The problem is not properly stated and it has 3 hints. And the number of answers is less, but the acceptance rate is high. I think we can do it, but the problem was not properly stated. We'll go through it again. You are given an integer array, okay? You are fine until this point. You can choose a set of integers and remove all the occurrences of these integers in the array. Okay? Return the minimum size of the set so that at least half of the integers of the array are removed. So I got it. Choosing 3, 7 will remove half of the entire array, or choosing 3, 5 will remove more than half of the array, or choosing 3, 2 will also remove more than half of the array. Choosing 5, 2 would also remove half of the array. So the possible sets are 5 comma 2 and exercise 2 or 3 comma 2, 5 comma 2, 3 comma 5. Choosing set 2 comma 7 is not possible as it will make the new array which has a size greater than half. So the least possible size is 2, and here if we choose to remove 7, the only possible set is 7, that will make the new array empty, which is more than half. So 7, at least half. Total equals to the length of array. Now we have to remove half, which will be total by 2. Let's make count equals to so that at least half of, you can choose a set of integers and remove all the occurrences of these integers. So we have to return the set we select with a minimum size. And return the minimum size also to pay. Or it will be better if return the minimum size of the set. We have to select least two least values that would make up to or greater than half. Array length will always be even. That's very helpful. And array length will be between 2 and 10 to the power of 5. And array values will be between 1 and 10 to the power of 5. So to make this predictable, sorted frequencies equals to sorted of count dot keys sorry equals to let's print the count and sorted frequencies. Let's make it more clear. Short frequency. So 7 has less, 3 has more. Well, we can use a 2-point approach, 5 and 2. We have only 1. And if length of count is 1, return 1. Uh, 0, comma, short frequency minus 1. While L is less than R. We don't know if we can reduce or increase. Let's see. We have to get a maximum frequency. Left value and right value will be short frequency of L and short frequency of R. If LV plus RV is greater than or equals to is exactly equal to the let's keep it in. It should be more easier to we have to do actually let's do one thing. Since we are not using N anywhere, let's take it as let's take the half. If L plus V is greater than half, if why do we need think it should be a cumulative value. So cumulative value equals to L plus R. The cumulative value is greater than of. The cumulative value is less than of, or else if it is exactly half, return the minimum size of the set so that that means we have to remove the maximum elements instead of the starting and last elements. Minimum size of the set. For the set to be minimum, I think we don't need this two-point approach. For I sort frequency, sorry, let's say cumulative equals to 0. If cumulative plus equals to cumulative is greater than or equals to half, can return we need count. Is not cumulative plus count. Push it. Let's keep it as frequency. Frequency. Well, this is looking great. And the constants are good for sorting distinct values, which will be 10 to the power of 5. So worst case scenario, the time complexity will be n log n, which will be 5 into 10 to the power of 5. Very considerable. So let's try submitting it. So well, this is great, but seems like there is a solution other than the sort frequency. But it is clearly greedy approach. Let's see what others did. Counting, sorted. Well, they did the same thing. Also, n minus count. Well, it is elegant. Values. Great. Instead of sorting the keys, they actually, that's great. But both of them are analog in time. So seems like there is no optimal solution other than this. Okay, wait a minute, max it, EP5. So that's it guys, I hope you guys understood the intuition. If you like the video, upload it and share it with your friends. And don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard guys. Goodbye. Also, don't forget to leave a comment so that we'll get a better reach and I can, what do we call it, address your problems and doubts. That's it guys, goodbye.